Alright, let's take a look at the last part of the review for Chapter 2, problems 19 and 20. And in number 19 they've given us a piecewise function that has a division defined at x equals -2. When it's less than, it's going to follow 5x squared. And then when it's greater than a -2, we're going to follow negative 20x minus 20, so a linear function. So the first thing we want to do is look at the question. It says, they give you a very big hint right here. They say, using the analysis of the continuity test and the left and right derivatives, if the function is differentiable at x equals -2. Well, they really gave us a little too much information, because one of the conditions for it to be a derivative, a possibility to take the derivative, is it must be continuous. So they really didn't have to give us that portion of information, but it's nice to have. So the first step we're going to do is we're going to check to see if the function is continuous, and then the next step we're going to do is we're going to find out what the derivative is equal to at x equals -2. Let me write that a little different. So we're going to look at the derivative at -2 for this function, and in order for us to do that, we're going to use what he's calling the left and the right hand, or the left and right derivative. So when it's to the left of -2, we're going to follow 5x squared, and when it's to the right, we're going to follow that linear function. So how are we going to check for continuity? Well, pretty simply, we're just going to plug in. We're going to look at the limit, and you don't, as x approaches -2 from the left, and we're going to just simply use 5x squared, and we're going to plug in -2, and then we're going to look to see the limit as x approaches -2 from the right hand side, and we're going to use the linear function. So every time we see x, we're going to plug in our value -2 and see what these two things are equal and check for continuity. -20 times x minus 20. Okay, so just doing a real quick analysis, of course this would be 4, and 4 times 5 is equal to 20. So this is what the limit is approaching from the left, and from the right here we have negative times negative, so we have 40 minus 20, which also equals 20. So the continuity test passed. So this thing, it's possible that it has the same derivative. We just have to actually calculate that. So we have a choice here to make. So test number 1 passes. So looking at test number 2, we can either use the limit as h approaches 0 to find the derivative of x, and we're going to have to do this twice because we have two piecewise defined here. So this would be, of course, just to review your limit definition of a derivative, all over h. So I think we'll do this one, and we'll just split this page up right in half, and we'll take a look at the first derivative, which is 5x squared. So it's the limit as h approaches 0 of 5 times x plus h, quantity squared, minus 5x squared, all over h. And of course we're going to FOIL this first term out with the h in it, and then distribute that 5 to it, and then do our simplification. So we have 5 times x squared plus 2xh plus h squared minus 5x squared. Let me go ahead and close my parentheses right there. All over quantity h. So when we distribute that, the numerator becomes 5x squared plus our 10xh plus h squared. That's 5h squared, sorry. Plus 5h squared minus 5x squared all over h. Okay, let me slide this part down here. And then finally, we can start canceling out. So we have 5x squared minus 5x squared. That term is canceled. And then the other two remaining terms both share an h. So I'm going to go ahead and factor. I suppose I could factor a 5 out. That's not really necessary. So let me just erase that. And we have h. We're left with 10x inside plus a 5h. All over h, and remember this is the limit as h is approaching 0. So now we're able to cancel that out. The h term cancels out. We directly substitute our h equals 0, and the derivative is equal to 10x plus 5 times 0, so it's just 10x. And now we're only interested what's happening at our when x equals negative 2. What's the derivative doing? So we have 10 times that negative 2, so our derivative is equal to negative 20. So now we have to do the same analysis using the second function, which is negative 20x minus 20. So let's try green on this one. Thus the limit as h approaches 0 of negative 20 x plus h minus 20 minus, be very careful right here, minus 20x minus 20 all over h. Alright, so go ahead and we'll distribute our negative to these two negative terms. And also, we're going to distribute a negative 20 to these two terms. So, word of caution on these negatives, just be careful. Minus 20x minus 20h minus 20, that's that one. And then that leaves us with a positive 20x and plus 20 all over h. So, let's start canceling things out if we can. We have a negative 20x, cancels that positive 20, and then we have negative 20 and a positive 20. So the only term left is that that term in the middle right here where we have negative 20 times h. So we're just going to factor out an h, and we're just left with negative 20 over h. And it's the limit as h is approaching 0. So once we simplify, cancel these two terms out, we're just left with negative 20. So there's no variable left. This is a linear term. So the slope of that second line is always negative 20, isn't it? So because of that, it looks like our two derivatives match up. So in fact, this is differentiable at x equals negative 2, even though this curve, one of them is a quadratic and the other one is a linear term, but at that spot they both share the same derivative. So this one is differentiable. Okay, number 20, the last problem in this review. It says use the letters associated with the points on the function to answer the questions, and I already have the answers up here. Now let's just kind of review them a little bit. It says the points at which the tangent line is horizontal, so that's kind of where I like to start anyways. And I would identify that we have a horizontal tangent, and that turns out to be a local maximum there. And then we have another local minimum at point D, so that's a spot of horizontal tangent, or the slope equals 0, or the derivative equals 0 there. Either way, it could be asked the same. It's asking about the same points. So when does this function have a root? I haven't really talked much about that since we did our algebra review, but where it crosses the x-axis, the function itself has a root. And remember, this is the graph of the function. And letter C says the point at which the function is negative and the derivative is positive. So everything below the x-axis, the function value is negative, and everything above has a positive function value. So all we have to do is look in there and see where the function value is positive and the derivative is positive. No, excuse me. Function value is negative and the derivative is positive. Well, there's only one spot in there that the function value is negative anyway, and it's A, but clearly you can see that this has a positive slope because the function is increasing there. And then finally, what points or point at which the function value is positive and the slope of the tangent line is positive? And it's, of course, at point E. At point E here. So, anyway, hopefully you're getting very comfortable at looking at the graphs, finding out where the behavior of the function by looking at its derivatives, and find out where it's positive, negative, and the slope is equal to 0. And also, hopefully you're very comfortable with our formulas for derivative. All right.